Right, new unit, factoring and greatest common factors. So we finally get to the quadratic section in the class, which is algebra with quadratics. So chapter 8 is all about doing quadratics and factoring quadratics, and I know we don't really know exactly what that means, but we'll talk about it. So today we're just doing greatest common factors, and this should be a little bit familiar. You guys have definitely done this in the past. We found greatest common factors of numbers, and we're going to add in a little bit of with variables, which is the algebra part, but hopefully should be a lesson that you guys are all familiar with. So to find the factors of a number, find two numbers that multiply to equal that number. So the factors of 12 are going to be 1 and 12, because 1 times 12 equals 12. And then 2 and 6 are also factors, so 2 times 6 equals 12. And then 3 times 4, also factors, because 3 times 4 equals 12. So all of them multiplied equal 12. So what are factors of 16? So I got to think to myself, and the obvious one, or the easy one maybe, is always to say 1 and 16. And then typically what I do next is I go to the next biggest number. So after 1 would be 2. And does 2 times anything equal 16? Yeah, it does. It equals 8. So then I go to the next one, and I would say 3. Does 3 times anything equal 16? Nope. Okay, so then 4. And 4 times 4 equals 16. So there's actually no more factors, and that's how far we go. I know I'm done because I got to the last one. And what I mean by last one is that I know there's no factors in between 8 and 16, because 1 times 16 and 2 times 8 are both factors. There's no number that can fit in the middle here, so there's no number that can fit in the middle there. So when I get to 4 and I do 4 times 4, well, there's no number in between 4 and 4, so I know that has to be the last one. So then let's also do 40. Once again, I'm going to start with 1 and 40. And then the next number is going to be 2. Okay. And feel free to pause the video, see if you can figure out the rest of these on your own, of the factors of 40. 2 times what equals 40? 2 times 20. So once again, I know there's no factors in between 20 and 40 then. So now I just have to check everything between 2 and 20, so something that could fit in the middle there. 3 times something, that's not going to work. 4 times something, that does work. Do 10. 5 times something, yep. Would be 8. And then, so now because I did 5 and 8, I just have to check things between 5 and 8. So 6 times something, does that equal 40? Nope. 7 times something, nope. And you can definitely do this too by using your calculator and doing 40 divided by it, right? So do 40 divided by 2. Yep, that works. So then we have 2 and 20. Then put in your calculator 40 divided by 3. Oh no, it's a crazy decimal, not going to work. So then 40 divided by 4. Oh, that equals 10. So then we have our 4 and we have our 10. And just keep doing that till you get down to the next biggest. So factors that are shared by 2 or more whole numbers are called common factors. The greatest of these common factors are called the greatest common factor, right? Math people, not creative. So if we look at our example here of the GCF of 12 and 32, we have here listed our factors of 12, which once again are these 6 numbers here, 1, 2, 3, 4, 6, and 12. And then we have our factors of 32, which would be 1, 2, 4, 8, 6, 32. So the common factors are highlighted in this blue color here. Our common factors are 1, 2, and 4 because they are factors of 12 and they are factors of 32. So they're common to both of those numbers. And then the greatest of the numbers, right, 1, 2, and 4, the biggest number is 4, so our greatest common factor of 12 and 32 is 4. So let's look back at the above example. Go ahead and what are common factors of 16 and 40? So common factors then will be 1, 2, 4, right? They occur in both of these, as well as 8. So now if we're looking for the greatest common factor, which of those numbers between 1, 2, and 4 is the biggest number? And so our GCF would be 8, because 8's the biggest number here. All right, so same thing with this bottom problem. So factors of 26 and 52. Go ahead and write out those factors, and then go ahead and write what is the greatest common factor. All right, so for this first one, common factors, if you see them in both, circle them. So you've got a 1 here and a 1 here. I see a 2 and a 2. I see a 13 and a 13, and a 26 and a 26. All right, what is the biggest number of the ones that we just circled? The biggest one is going to be 26. So our greatest common factor is 26. All right, go ahead and try the next one for practice. 160. Pause video. All right, so I just underlined the common factors here. So lots of factors of 100, lots of factors of 60. Hopefully you found them all. And then, so looking at the common factors, we have 1, 2, 4, 5, 10, and 20. So what is the greatest number between them that they share? 20 would be our greatest common factor. All right, and here, putting the algebra in here a little bit, let's find the greatest common factor of each pair of monomials. So I have 15x cubed. And I want to write that out, kind of all the factors of that. So we're going to start with just the 15. And when I look at what are factors of 15, I can do 1, 15, 2 doesn't work, 3 does, 3 times 5, and then 4 also doesn't work, so there's nothing in between 3 and 5. So 1, 3, 5, and 15. Not 14, sorry about that, 15. And then also, we need to write out, how do we make x cubed? Well, that's going to be x times x times x. So let's remember that. Now let's do the factors of 9x squared. So 9 is going to be 1 and 9, and then just 3, because 3 times 3 equals 9 as well. And then to do x squared, we have x times x. So the first part of finding the GCF of 15 and 9. So just do the exact same thing we did. Find your common factors, so 1 and 1, 3 and 3. So then my greatest common factor is going to be 3. And then you need to see how many x's are common for both of these, right? So here I see 1, 2, 3 x's. Here I only see 2. So you could say that they both have 2 x's. So x squared is going to be part of my greatest common factor. So you want to look for whoever has the least amount. So x and x, there's 2 of them there, there's 3 of them there. So you can say both of them have at least 2. All right, and last problem, 2745. Try to do this on your own. Pause your video, and then come back and check out the answer. All right, so our answer for this one is 9x squared. Hopefully you got that as well. 27 and 45, so there are the factors. So 9 is our greatest common factor. And then we take a look at our x's. I have 2 x's here, and I have 3 x's and a y here. So first of all, is the y a factor of both of these? Do you see a y in both parts? No. So y is not going to be part of my answer there. But I do see an x and an x, and I see an x and an x. So there is an x squared in both of them. So then 9x squared is what we're going to do there. Once again, if the variable part was a little bit tougher, that's okay. That's what we're going to work on. But today we want to just make sure that you're really good at common factors.